Hey, AP Calc students, Mr. Antonucci here. In this video, we're going to start talking about interpreting a derivative and specifically about the slope of a tangent line. First thing we need to discuss, though, is average versus instantaneous rate of change. If we let f be defined over some open interval containing the number c, the average rate of change is just f of x minus f of c all over x minus c, which is change in y over change in x. However, the derivative of f at c is denoted f prime of c, and that is equal to the limit of the average rate of change as x approaches c. And we've looked at it like with this limit here. So an average rate of change measures the change in f from c to x, while the derivative measures the change exactly at x equals c. So let's look at an example. We want to find the derivative of f, then find the slope of the tangent line to the graph of f at the point 0, f of 0, write the equation of the tangent line at that point, and then we'll graph everything. So the first thing we need to do is take the derivative to get f prime. And since it's x times cosine x, we'll need to use the product rule, derivative of the first times the second, plus the first times the derivative of the second. And since the derivative of cosine is negative sign, I'll put the negative there, plus the derivative of x is 1, and then the derivative of minus 1 is going to be 0. So the slope is the derivative evaluated at 0. Cosine of 0 is 1 minus 0 times sine of 0 would still be 0. So we're going to get 2. So we found the derivative. We found the slope of the tangent line. Now we need to write the equation of the tangent line. Since they gave us the point as 0, f of 0, we need to find what f of 0 is. And that's going to be negative 1. So the point is 0, negative 1. Then our equation of the tangent line, y minus y1, which would be plus 1, equals the slope, 2 times x minus x1, which is 0. If we solve that for y, you would have y equals 2x minus 1. We'll hop on over to Desmos and graph that. All right, so we got the graph in red. We have the point highlighted in blue, and then the equation of our tangent line. We zoom in, we can see that as we get closer to this point, the tangent line starts to really look like it has the same slope as the graph at that point. Okay, here's another one, same type of problem, just going to use a different function here. So the first thing we want to do is find the derivative, which we would have to use the quotient rule. The derivative of the top is going to be u prime e to the u using the chain rule times the bottom minus the derivative of the bottom, which would be negative sine, which makes the subtraction plus sine x times e to the 3x all over the denominator squared. And I would recommend leaving it like that because the next step is to evaluate it at the point. So when we plug in 0, the denominator is going to be cosine of 0, which is 1, squared, which is still 1. We would have the 3 here. E to the 3x, when you plug in 0, would be e to the 0, which is just 1. And then cosine of 0 is just 1. Plus, here, when we plug 0 in for x, sine of 0 is 0, so it makes that whole term equal to 0. And then we just get 3. Then if we want to write the equation of the tangent line, we need to figure out what the value of y is. So if we plug 0 in, it'd be e to the 3 times 0 over cosine of 0. So this is going to be 1 over 1, or just 1, which implies the point 0, 1. Now we can write the equation of the tangent line, y minus y1 equals the slope, 3 times x minus x1, which is 0. If we solve that for y, we would have y equals 3x plus 1. We'll hop over to Desmos and graph that. Okay, so we have the graph of f in purple. We have the point highlighted in black here, and the equation of the tangent line, y equals 3x plus 1, confirming that we have a reasonable answer. All right, guys, that's it for interpreting a derivative as the slope of a tangent line. Hope that was helpful to you. Make sure you subscribe, leave me a comment below, and like this video.